Let's define some more vocabulary words that we're going to use to describe redox reactions. Just to review, redox refers to oxidation reduction reactions in which electrons are transferred between different chemical compounds. So one phrase we need to define is the oxidizing agent. The oxidizing agent is a species on the left side of the reaction, so it's a reactant that oxidizes some other reactant. So the oxidizing agent oxidizes something else, and in the process, it becomes reduced. So the oxidizing agent gets reduced over the course of a redox reaction. Conversely, the reducing agent is a species on the left side of the equation that reduces another reactant. So a reducing agent is a reactant that reduces something else. And as a consequence, the reducing agent itself becomes oxidized over the course of the redox reaction. So the oxidizing agent gets reduced. The reducing agent gets oxidized. Once again, you should know that oxidation involves loss of electrons and reduction involves gain of electrons. So there's really a lot of vocabulary to master here. Let's do an example. Let's look at this unbalanced redox reaction where iron 3 plus reacts with tin 2 plus to make iron 2 plus tin 4 plus. Sn is tin. So let's figure out how electrons are being transferred in this reaction. Here we have monoatomic ions. So for all of these ions here, their oxidation states are simply equal to the ion's charge. So we don't need to figure out any oxidation states here. Let's look at Fe3 plus and what happens to it as we go from left to right. Fe3 plus becomes Fe2 plus. So in order to become less positive, it must be gaining an electron, right? It has to gain an electron, one electron, to go from 3 plus to 2 plus. Gain electrons is reduction. So that means that over the course of the reaction, the Fe3 plus becomes reduced. That means if it becomes reduced, that it must be the oxidizing agent. Okay, I know this is very confusing. It's very confusing vocabulary. It is the oxidizing agent because it becomes reduced going from left to right. The oxidizing agent gets reduced. Now let's look at tin. Tin is going from the 2 plus oxidation state to the 4 plus oxidation state. It's becoming more positive. And if it's becoming more positive, that's because it's losing electrons. And each tin has to be losing 2 electrons here to go from the 2 plus to the 4 plus state. That means that tin is being oxidized. So this is undergoing oxidation. So that means looking at the reactant Sn2 plus, this must be the reducing agent. The reducing agent becomes oxidized over the course of the reaction. I want to point out that this reaction is occurring in aqueous solution. And if we look 3 plus plus 5 plus, this is not a balanced reaction. The elements look balanced, but the charge is out of whack. We are not going to balance redox reactions in aqueous solution this semester. I'm going to save that for next semester. We're going to balance redox reactions next semester. So that means we'll be skipping section 6-10 of the book, just for now. Now, I would like to do a couple more problems. Assign oxidation states to all elements and identify the oxidizing agent and the reducing agent in the following reactions. Okay, so the first reaction I would like you to do is silicon tetrachloride plus 2 magnesiums gives magnesium chloride plus silicon. In this case, I have given you a balanced reaction. So I want us to proceed in order. First, let's assign all the oxidation states to all the elements in the reaction. And we need to do that before we can identify which one is being oxidized and which is reduced, and therefore which is the oxidizing agent and which is the reducing agent. So we have to use our powers of deduction. Some things are easier than others. If I see an element all by itself, like magnesium here, its oxidation state is going to be 0. Okay, so a free element all by itself is going to have an oxidation state of 0. So both the magnesium and then the silicon on the right side are going to have oxidation states of 0. The others are a little trickier. Now, halogens are usually anionic species with oxidation states of -1. Okay, so when in doubt, assign a halogen -1. This will help us figure out what the oxidation state of silicon should be. And if the halogen is -1 and I have 4 of them, then I'm going to need a 4 plus oxidation state on the silicon to balance out the 4 minus from the 4 chlorines. If you look at the periodic table, 4 plus is the charge that silicon tends to take in compounds. Over on the right side of the equation, you know that magnesium in compounds is an alkaline earth element, so it's always 2 plus. And that means since I have 2 chlorines in the compound here, each of them is going to be -1. So now let's figure out which element is being oxidized and which element is being reduced. So chlorine is -1 on both sides. So nothing is happening to it redox-wise going from left to right. But silicon is going from 4 plus to 0. 4 plus to 0 is a major reduction, right? It's a 4 electron reduction. It has to be gaining 4 electrons to have its oxidation state reduced from 4 plus to 0. So silicon is being reduced over the course of the reaction. And since that element is being reduced, then this reactant would be called the oxidizing agent. Now remember, the oxidizing agent is the species that becomes reduced. This is confusing, so that's why I want to go over it several times. Conversely, we have magnesium going from 0 to 2 plus. And that is certainly an oxidation. It's losing, each magnesium is losing 2 electrons. So that means that solid magnesium is going to be the reducing agent because it becomes oxidized over the course of the reaction. So a few things here. The element silicon is reduced. The compound SiCl4 is the oxidizing agent. Let's do another example. In this example, I have nitrate, NO3 minus, plus Fe2 plus a proton, H plus, giving NO, so nitrogen monoxide, plus Fe3 plus water. I want to point out that this is not a balanced redox reaction, and I do not expect you to be able to balance redox reactions yet. We're going to do that next semester. But I do expect you to be able to assign oxidation states to all of the elements in this reaction and then tell me what the oxidizing agent and the reducing agent are. So in nitrate, NO3 minus, I have a 2 minus on the oxygen and the overall charge on the ion is -1. So that means I have to have a 5 plus on the nitrogen. We actually did that one in a previous lecture. Each oxygen is going to be 2 minus, an oxidation state of 2 minus on each oxygen. Iron is 2 plus, okay, so that one's done. The oxidation state is equal to the ion's charge. H is just +1. Now here, oxygen is -2 always, so that means that in a neutral compound, the nitrogen has to be 2 plus. Iron is Fe3 plus. The oxidation state is the ion's charge. And here, oxygen is going to be 2 minus, and each hydrogen is going to be plus 1. So now, let's look at what's changing and what isn't. Going from left to right, oxygen is 2 minus. The oxidation state of oxygen is not changing. The oxidation state of hydrogen is not changing going from left to right. You can see that it's plus 1 on the left and plus 1 on the right. However, nitrogen is going from 5 plus to 2 plus. It's becoming less positive. That means it must be gaining electrons. So nitrogen is going to be reduced. The nitrogen is gaining 3 electrons to go from 5 plus to 2 plus. Now, that leaves iron. By process of elimination, iron must be getting oxidized. You can't have reduction without oxidation. And it's true, iron is going from 2 plus to 3 plus. It's becoming more positive. That's a 1 electron oxidation. It's gaining 1 electron. So this is going to be oxidation. So if nitrogen is being reduced, that means that nitrate is the oxidizing agent, because the oxidizing agent becomes reduced. And since iron is being oxidized, then Fe2 plus is going to be the reducing agent. So I want you to be able to look at redox reactions, assign oxidation states to all elements involved in those reactions, and then figure out which element is being oxidized, which element is being reduced, and what the oxidizing agent and reducing agent are.